capacitors of capacitances C1 is equal to C2 is equal to C3 is equal to C4 is equal to 10 microfarad and C5 is equal to 2.5 microfarad are connected as shown along with the battery of 50 volt. The equivalent capacitance and the charges on each capacitance respectively are 4 microfarad, 250 microcoulomb on C1 to C4 and 125 microcoulomb on C5. 5 microfarad, 250 microcoulomb on all capacitors, 5 microfarad, 125 microcoulomb on C1 to C4 and 225 microcoulomb on C5. 5 microfarad, 125 microcoulomb on all capacitors. C1, C2, C3 and C4 are in series. Suppose इनका resultant is C dash. So C dash will be 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 इसका reciprocal 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10 reciprocal. This will be 10 by 4 2.5 माइक्रोफैरड. अगर इनको यहाँ से हम रिमूव कर दें, हटा दें और इसकी जगह एक कैपेसिटर ऑफ कैपेसिटेंस सी डैश ऐड कर दें तो सर्किट पर कोई इफेक्ट नहीं होगा. दिस इज सी डैश. C5 and C dash are in parallel, hence resultant capacitance will be C dash plus C5. 2.5 plus 2.5 is equal to 5 microfarad. The equivalent capacitance will be 5 microfarad. This is 2.5 microfarad C5 and this is also 2.5 microfarad. तो चार्ज ऑन C5 अगर हम इसको Q5 से डिनोट करें, that will be C5 into voltage V, 2.5 microfarad into 50, 125 microcoulomb. चार्ज ऑन C डैश अगर इसको QC डैश से डिनोट करें, that will be 2.5 into 50, 125 माइक्रोफैरड. जो C डैश पर चार्ज होगा वही C1, C2, C3 एंड C4 पर होगा. इसलिए Q1 is equal to Q2. ये Q1 is charge on C1, Q2 is charge on C2 and Q4 is charge on C4. That will be equal to QC dash and 125 microcoulomb is the coulomb माइक्रोकूलम्ब. तो सभी पर जो चार्ज होगा that will be 125 microcoulomb and resultant capacitance will be 5 microfarad. D is correct option. Next, consider two uncharged capacitors of equal capacitance 200 picofarad. One of them is charged by 100 volt supply and disconnected. Now this is connected to uncharged capacitor. The amount of electrostatic energy lost in the process is 0.5 joule, 1.0 into 10 to the power minus 6 joule, 0.5 into 10 to the power minus 6 joule, 1 joule. जो कैपेसिटेंस है दैट इज 200 picofarad or 2 into 10 to the power 12 farad or 2 into 10 to the power minus 10 farad. एक कैपेसिटर इसको हमने जोड़ दिया एक बैटरी से जिसकी वोल्टेज V इज 100 वोल्ट. सी कैपेसिटेंस. इस पर चार्ज विल बी Q and Q is CV. C is 2 into 10 to the power minus 10 and V is 100. 2 into 10 to the power minus 8 coulomb. Energy stored is half CV square, half into 2 into 10 to the power minus 10 into 100 का स्क्वायर 1 into 10 to the power minus 6 जूल. चार्ज. now it is disconnected and इसको सिमिलर कैपेसिटर से जोड़ दिया गया. चार्ज विल बी redistributed एंड क्योंकि सेम है सिमिलर हैं इसलिए चार्ज विल बी हाफ एंड हाफ. E2 energy stored will be 2 into अगर इसको हम स्मॉल q से डिनोट करें हाफ q स्क्वायर बाय c. This is q square by c and q is q by half square by c, half q square by c, and q is 1 upon 2 and q is 2 into 10 to the power minus 8 by square by c. q square by this will be 1 by 4 q square by c or 1 by 4 q is 2 into 10 to the power minus 8 का स्क्वायर and c is 2 into 10 to the power minus 10. One by 4 into 4 into 10 to the power minus 16 by 2 into 10 to the power minus 10. This is 0.5 into 10 to the power minus 6 joule. The lost energy will be E1 minus E2 1 into 10 to the power minus 6 minus 0.5 into 10 to the power minus 6 0.5 into 10 to the power minus 6 joule. The C is correct option. Next, three identical capacitors P, Q and S, each of capacitance C, are connected to a battery of voltage V as shown in the figure. If the energy stored in the capacitance P and total energy stored in the system are UP and UT respectively, then the ratio of UP by UT is. P and C are in P and Q are in parallel, hence the resultant is a M, the capacitance of resultant of P and Q is C dash. So C dash will be inverse of this 1 upon C plus 1 upon C का इनवर्स C by 2. तो C by 2 अगर यहाँ से हम इसको डिसकनेक्ट कर दें और यहाँ पर C by 2 कैपेसिटी का कैपेसिटेंस ऐड कर दें, दिस इज C dash. Resultant of C and C dash is C double dash and ये पैरेलल में है C dash और S जो है, तो इनका रिजल्टेंट होगा C dash प्लस C और C by 2 प्लस C 3C by 2. इसका रिजल्टेंट यहाँ पर हमने अगर यहाँ ऐड कर देंगे, हम C डबल डैश कर इनको सबको हटा दें तो इस पर सर्किट पर कोई इफेक्ट नहीं पड़ेगा. तो एनर्जी UT विल बी हाफ C डबल डैश V स्क्वायर, हाफ 3C by 2 into V square 3 by 4 CV square. Now, charge on C dash will be C dash into V C by 2 into V. And this will be equal to charge Q on P. UP will be half Q square by C, half 1 by 2 Q is CV by 2 by square, and this will be 1 by 8 CV square. तो रेशो होगा UP by UT is equal to 1 by 8 CV square by 3 by 4 CV square, and that is 1 by 6. This A is correct option. Next, consider a fixed uniformly charged insulating sphere with radius r and total charge q. A point charge minus q, q is very small, then the capital Q with mass m is released from rest at distance of 3 r from the center of charge sphere. When the point charge reaches the surface of sphere, its speed is epsilon dot is the permittivity of vacuum, neglect gravitational forces. एक charged sphere, इसकी radius is r. इस पर जो total charge है that is q. जो स्फीयर का चार्ज इज एज्यूम्ड टू बी कंसंट्रेटेड एट सेंटर से 3r डिस्टेंस पर माइनस क्यू चार्ज, दिस इज 3r। तो इस कंडीशन में टोटल एनर्जी E1 will be potential energy U1 plus kinetic energy. Speed of this charge is 0, hence kinetic energy is 0, and U will be 1 upon 4 pi epsilon dot Q minus Q by 3r plus 0, or minus Q upon 4 pi epsilon dot r, 3r। अब this particle या this charge goes on this surface माइनस क्यू, यहाँ पर इसकी स्पीड सपोज v, तो सेकंड कंडीशन में E2 होगा U2 प्लस K2 एंड U2 पोटेंशियल एनर्जी एट दिस पोजिशन विल बी माइनस QQ अपॉन 4 पाई एप्सिलॉन 0 R, and kinetic energy is half mv square। एनर्जी कंजर्वेशन से E2 will be equal to E1 और माइनस क्यू के अपॉन 4 पाई एप्सिलॉन R प्लस हाफ mv स्क्वायर इज इक्वल टू माइनस क्यू अपॉन 4 पाई एप्सिलॉन डॉट इंटू 3r। तो हाफ mv स्क्वायर विल बी QQ by 4 pi epsilon dot r minus QQ upon 4 pi epsilon dot into 3r, or QQ upon 4 pi epsilon dot into 3r, 3 minus 1, 2QQ upon 4 pi epsilon dot into 3r half mv square। इस 2 से 2 and this 2 will be here, तो v square is equal to QQ upon pi 3 pi epsilon dot r into m। तो v will be QQ upon 3 pi epsilon dot mr का रूट। This D is correct option। Next, a unit positive charge is taken slowly through an infinitesimally thin tube that is inside a charged electric sphere of radius r having uniform positive charge rho as shown in the figure. The initial and final position of the charge are marked by A and B at distance 2r and 3r respectively from the center of the sphere. In this process, the magnitude of total work done on the point charge is rho r square by n epsilon dot. The value of n is epsilon dot is permittivity of the vacuum 18, 2, 6 and 9. This is unit, यहाँ पर एक यूनिट पॉजिटिव चार्ज 1, Q is 1। जो स्फीयर पर टोटल चार्ज है दैट इज Q, and Q is rho charge density into volume, charge density into 4 by 3 pi r cube. जो Q है, it is assumed that this is at O. Work done is difference of potential energy at A and B. तो difference होगा Q into Q by 4 pi epsilon dot into 2r minus QQ upon 4 pi epsilon dot 3r. Q by 4 epsilon dot r 1 by 2 minus 1 by 3 QQ upon 4 pi epsilon dot r into 1 by 6 1 by 24 pi epsilon dot r. Q is capital Q rho into 4 by 3 pi r cube and small q is 1. 6 पाई से पाई क्रॉस हो जाएगा, रो r स्क्वायर बाई 18 एप्सिलॉन डॉट एंड दिस इज इक्वल टू रो r स्क्वायर जो गिवन है रो r स्क्वायर अपॉन n एप्सिलॉन डॉट. हैंस n इज 18. n की वैल्यू इज 18. दिस A is correct option.